So, good morning class. Today we will further discuss the chemical reactions which we discussed in those categories which are not shown by alcohols or the reactions which are only the characteristic features of phenols. So, we have already discussed 5 reactions and we will discuss the more in the coming details. So, our next reaction is reaction of, that is condensation of phenol with formaldehyde. That we can say as HCHO. This is our formaldehyde molecule. HCHO, this is our formaldehyde molecule. So, this is our next reaction, this is 6th reaction, wherein we have to see the condensation of phenol with formaldehyde. So, what happens? So, this is our phenol molecule. This is our phenol molecule, and when it is treated with HCHO, this is our formaldehyde. So, what it does? This formaldehyde molecule introduces CH2OH group at ortho position and also at para position. So, what happens during the product formation? So, we have two main products, one is ortho derivative and the other one is para derivative. So, this is ortho derivative and the other one is para derivative. And the other one is para derivative. So, these are the two products, ortho and para substituted products. This is called orthophenol or it is called orthohydroxy benzyl alcohol and it is called para-hydroxy benzyl alcohol. So, these two products are formed when phenols are condensed or reacted with formaldehyde. So, what happens during the condensation of phenol with formaldehyde, that is HCHO molecule? What happens when phenol is treated with HCHO? Then what happens? This HCHO or formaldehyde molecule, it introduces benzyl group, CH2OH group at mainly at ortho position and para position. So, it involves two product formation, ortho and para substituted products. So, the first product which is formed is orthohydroxy benzyl alcohol and the other one is para-hydroxy benzyl alcohol, and again this para substituted product is more stable. So, again this para substituted product is more stable. So, this is the entire mechanism behind the condensation of phenol with formaldehyde. Fine. So, let us move to the next reaction, that is 7th reaction. This is 7th reaction, that is condensation of phenol, with phthalic anhydride, condensation of phenol with phthalic anhydride. So, what happens during the entire course of reaction? This is the molecule of phthalic anhydride. This is one molecule of phthalic anhydride. So, it is treated with two molecules of phenol So, what happens? This leads to the elimination of a water molecule in the form of H2O, two hydrogens from phenolic groups and one oxygen from this phthalic anhydride. So, this is our phenol, first molecule of phenol, and this again a phenol molecule, and this is the liberation of water molecule. So, when this happens in the presence of concentrated sulfuric acid, which is a dehydrating agent, so water molecule is eliminated and the product which is formed is like this. Like this, and this carbon which will be linked to this, and it will be further linked to this group, and here it will be OH, and the same linkage would be on this side. This OH, and this compound is nothing but phenolphthalein, which is an acid base indicator. It is used as an indicator in titration reactions. So, this is molecule of phenolphthalein. So, this is the process of entire mechanism of condensation of phenol with phthalic anhydride. So, this is the molecule of phthalic anhydride. When it is treated with two molecules of phenol, so water molecule is eliminated in the form of oxygen from this phthalic anhydride molecule and the two hydrogen atoms from the two phenol groups of benzene ring of phenolic group. So, when it is treated with concentrated sulfuric acid, since concentrated sulfuric acid is a dehydrating agent, it removes a water molecule, and after the water molecule is eliminated, these two phenolic groups are attached as shown like this, and this compound which is formed, it is called phenolphthalein, and it is used as an indicator in acid base titration reactions. So, this is the overall mechanism of formation of phthalic anhydride reaction, condensation of phenol with phthalic anhydride. Now, let us see the next mechanism, 8th one. The next mechanism is Kolb-Schmitt reaction. Kolb-Schmitt reaction. So, what happens during Kolb-Schmitt reaction? So, this is our sodium phenoxide. It is reactant with carbon dioxide. Carboxylation takes place in the presence of 400 Kelvin and 6 to 7 atmospheric pressure. So, what will happen? This CO2 will be attached over here. So, this was our phenol and O. So, this CO2 would be attached in this form, C double bond O, carbon dioxide, and after that Na. This is the intermediate step which is formed. So, this CO represents carboxylation which took place, and after that it undergoes a rearrangement to form, here it will be OH and here it will be COONA, and after that when it is treated with dilute HCl, then NaCl would be eliminated and finally leads to the formation of salicylic acid. Salicylic acid. Or it is also called orthohydroxy benzoic acid. So, this is the half mechanism of Kolb-Schmitt reaction, and from this entire mechanism of Kolb-Schmitt reaction we have to see three syntheses. The three syntheses are, first one is formation of aspirin, second one is formation of Salol which is called phenyl salicylate, and the third one is formation of methyl salicylate. And all the three preparations we have to see from salicylic acid. So, this is the entire mechanism of Kolb-Schmitt reaction or Kolb-Schmitt process. So, first of all, sodium phenoxide is carboxylase. It is treated with carbon dioxide and in the presence of 400 Kelvin and 6 to 7 atmospheric pressure. What happens? This CO2 is attached over here in the form of COO. After this, this compound undergoes rearrangement to form sodium salt of salicylic acid, and finally, when it is treated with dilute HCl, so one molecule of NaCl is eliminated and finally it forms salicylic acid, or it is also called orthohydroxy benzoic acid. And from this salicylic acid we have to see further three syntheses. First one is formation of aspirin, second one is formation of Salol, that is phenyl salicylate, and the third one is formation of methyl salicylate. And this methyl salicylate is an important constituent of oil of wintergreen, oil of wintergreen. So, we shall move forward. So, we have to see the three syntheses. Let us see from the first one, or A, that is synthesis of aspirin from salicylic acid. Synthesis of aspirin from salicylic acid. So, let us start. This is our salicylic acid. So, this is our salicylic acid. When it is treated with acetic anhydride, in the presence of GAA, GAA is nothing but it is glacial acetic acid, purest form of acetic acid. What happens? A molecule of acetic acid is eliminated, and after the elimination of water molecule, how it will be eliminated? It is eliminated in this form: hydrogen from this atom and CH3COO group from this atom, and further this group attaches over here, leads to the formation of O, CuCH3, and this is COOH, and this compound is known as aspirin, or it is also called as 2-acetoxy benzoic acid, 2-acetoxy benzoic acid. And this aspirin which is formed, it acts as a analgesic and also as a antipyretic. So, this is the synthesis of aspirin from salicylic acid. When salicylic acid is treated with acetic anhydride, what happens? In the presence of glacial acetic acid, a molecule of acetic acid is eliminated, and the rest, this COCH3 groups attaches over here, leads to the formation of aspirin, or its IPC name is 2-acetoxy benzoic acid. And this aspirin which is formed, it acts as an analgesic also and antipyretic also. Now, these analgesics and antipyretics are two types of drugs, chemical substance. One form reduces the body temperature during high heat or fever conditions, and the other relieves during pain, that is acts as a painkiller. So, aspirin it acts as it reduces the temperature of the body, as well as it also acts as a painkiller. So, thank you class.